Welcome to another exciting episode of Low-Level Programming Crashcasts. I'm your host, Sheila, and today we're diving into a fundamental concept in programming, the difference between static and dynamic linking. Joining me, as always, is our expert, Victor. Hey, Victor, ready to unlink some mysteries?
Hey Sheila, absolutely, I'm all linked up and ready to go.
Great. Before we dive in, let me quickly outline what we'll be covering today. We'll start with a brief history of linking, explain the basic concepts, discuss advantages and disadvantages, look at real-world implementations, and even touch on some common misunderstandings. But first, let's kick things off with a quiz question for our listeners. Here goes. In which scenario would you typically prefer dynamic linking over static linking? A. When distributing proprietary software. B. When creating a small standalone utility. C. When working with embedded systems. D. When prioritizing faster load times. Victor, any thoughts on this without giving away the answer?
Ooh, that's a tricky one, Sheila. Each of those scenarios has its own considerations. I think our listeners will need to think carefully about the trade-offs involved in each situation. It's not as straightforward as it might seem at first glance.
Excellent. We'll reveal the answer at the end of the episode. Now, let's start at the beginning. Victor, can you give us a brief history of linking in programming?
Certainly, linking has been around almost as long as programming itself. In the early days of computing, programs were small enough to be written and loaded into memory as a single unit. But as programs grew more complex, it became necessary to split them into smaller, manageable parts. The concept of linking emerged in the 1940s and 1950s, with the development of the first assemblers and compilers. Initially, all linking was static, meaning that all code was combined into a single executable at compile time. Dynamic linking came later, in the 1960s and 1970s, as operating systems became more sophisticated and memory management improved.
Interesting. So, linking evolved to solve the problem of managing increasingly complex programs. Now, could you explain the basic difference between static and dynamic linking for our listeners?
Of course. At its core, the difference is about when and how different parts of a program are combined. Static linking is like baking a cake. You mix all the ingredients, your code and libraries, together before you put it in the oven, compile it. The result is a single, self-contained executable file that includes everything it needs to run. Dynamic linking, on the other hand, is more like assembling a sandwich. You keep the ingredients, libraries separate, and only put them together when you're ready to eat. Run the program. The executable file contains references to the libraries it needs, but doesn't include the library code itself.
That's a great explanation, Victor. So if I understand correctly, with static linking, everything is bundled together at compile time, while with dynamic linking, some parts are only brought together at runtime. Is that right?
Exactly right, Sheila. You've got the core concept down perfectly.
Thank you. Now, I've heard another analogy comparing static and dynamic linking to books. Could you elaborate on that?
Certainly, think of static linking like a physical book. Everything you need to read the story is contained within the book itself. You can take it anywhere and read it without needing anything else. Dynamic linking is more like an e-book reader. The device, your program, doesn't contain all the books, libraries itself. Instead, it downloads the books, loads the libraries, as needed when you want to read them.
That's a helpful analogy. Thanks. Now, what are some advantages and disadvantages of each approach?
Great question. Static linking has the advantage of simplicity and portability. Since everything is in one file, you don't have to worry about managing multiple libraries or version conflicts. It can also lead to faster startup times since everything is already loaded. However, statically linked programs are larger, which can be a disadvantage in terms of disk space and memory usage. They're also less flexible. If a library is updated, you need to recompile the entire program to benefit from the update. Dynamic linking, on the other hand, results in smaller executables and more efficient memory usage, since multiple programs can share the same libraries. It's also more flexible, allowing libraries to be updated without recompiling the programs that use them. The main disadvantages of dynamic linking are potential compatibility issues if library versions change, and slightly slower startup times as libraries need to be loaded at runtime.
That's really helpful, Victor. Can you give us some examples of where we might see static and dynamic linking in real-world applications?
Absolutely. Static linking is often used in embedded systems, or when creating small, standalone utilities where simplicity and portability are key. For example, many command-line tools on Unix-like systems are statically linked. Dynamic linking is more common in desktop and server applications. Most of the applications you use on your computer, like web browsers, office suites, and even the operating system itself, use dynamic linking. This allows for easier updates and more efficient use of system resources.
Interesting. Are there any edge cases or challenges we should be aware of when it comes to linking?
Indeed there are, Sheila. One challenge is the dependency hell that can occur with dynamic linking, where complex chains of library dependencies can lead to conflicts or compatibility issues. Another interesting case is position-independent code, or PIC for short, which is crucial for dynamic linking but can sometimes impact performance. PIC allows code to be loaded at any memory address, which is necessary for shared libraries but can introduce some overhead. There's also the security aspect to consider. Statically linked programs are more resistant to certain types of attacks that target shared libraries, but they're also harder to patch if vulnerabilities are discovered in the included library code.
Those are important considerations, Victor. Are there any common misunderstandings or pitfalls that programmers should watch out for?
Absolutely. One common misconception is that dynamic linking always leads to smaller executables. While the executable itself is smaller, the total disk space used can actually be larger when you account for all the shared libraries. Another pitfall is assuming that dynamically linked programs will always use the latest version of a library. In reality, it depends on how the system is configured and how the program specifies its dependencies. Lastly, some developers underestimate the complexity of managing dependencies in large dynamically linked projects. It's important to have good practices around versioning and dependency management to avoid issues.
Those are great points, Victor. Speaking of good practices, do you have any tips or best practices for developers working with linking?
Certainly. Here are a few key tips. 1. Choose your linking strategy based on your project's needs, not just default settings. 2. For dynamically linked projects, use clear and specific version requirements for your dependencies. 3. Consider using tools like static analysis to detect potential linking issues early. 4. Be aware of licensing implications, especially when statically linking libraries. 5. For performance-critical applications, profile your code to understand the impact of your linking choices. Remember, there's no one-size-fits-all solution. The best approach depends on your specific use case.
That's really helpful, Victor. Now, I'm curious, do you have any fun or interesting facts about linking?
Oh, I've got a good one. Did you know that the term link in this context comes from the early days of computing when programs were literally linked together using physical wires on plugboards? It's a great example of how programming terminology often has roots in physical, real-world concepts.
That's fascinating. Before we wrap up, could you give us a quick memory trick to help remember the key difference between static and dynamic linking?
Sure thing. Think static stays, dynamic downloads. In static linking, everything stays together in one file. In dynamic linking, the program downloads, or loads, what it needs at runtime.
That's a great mnemonic, Victor. Now, let's reveal the answer to our quiz question. The question was, in which scenario would you typically prefer dynamic linking over static linking? And the correct answer is A. When distributing proprietary software. Dynamic linking is often preferred for proprietary software because it allows the core code to be updated without requiring a full redistribution of the software. It also makes the executable smaller and can help protect proprietary algorithms by keeping them in separate, potentially encrypted libraries. Victor, Could you summarize the main points we've covered today?
Certainly, Sheila. Here's a quick recap. 1. Static linking combines all code into a single executable at compile time, while dynamic linking loads libraries at runtime. 2. Static linking offers simplicity and portability, while dynamic linking provides flexibility and efficiency. 3. The choice between static and dynamic linking depends on the specific needs of your project. 4. Both approaches have their challenges, including dependency hell for dynamic linking and larger file sizes for static linking. 5. Best practices include choosing your linking strategy deliberately, managing dependencies carefully, and being aware of performance and security implications. Remember, static stays, dynamic downloads.
Excellent summary, Victor. If we had more time, we could have delved deeper into topics like lazy loading in dynamic linking, the intricacies of symbol resolution, or even the impact of linking choices on software distribution and updates. But for now, that brings us to the end of today's episode. We hope you found it informative and engaging. If you enjoyed the show, please don't forget to subscribe and leave us a rating. Your feedback helps us improve and reach more developers. Join us next time when we'll be discussing another fascinating topic in low-level programming. Until then, keep coding and stay curious.